In this lecture, we'll talk about transactions, blocks, and mining. Transactions are the heart of the Ethereum blockchain. Interacting with the Ethereum blockchain means executing transactions that update blockchain state. The term transaction is used in Ethereum to refer to the signed data package that stores a message to be sent from an externally owned account to another account on the blockchain. Also, the contracts have the ability to send messages to other contracts. An user account produces a transaction and the contract produces a message. Let's see now what is the life cycle of an Ethereum transaction. First, the client constructs the raw transaction object. Then, the client signs the transaction and validates it locally. In order to sign the transaction, the client needs access to the private key. If using a web application like my Ether wallet or a browser plugin like MetaMask, that application connects to an Ethereum node that in turn broadcasts the transaction to its peers, which in turn broadcast to their peers, and so on. The node returns a transaction ID which can be used to track the status of the transaction on a blockchain explorer like Etherscan. At the third step, the transaction is broadcasted to the network by the Ethereum client and the transaction ID or hash, a transaction ID or transaction hash is the same, is returned. A miner node accepts the transaction. Ethereum network has a mix of miner nodes and non-miner nodes. The transaction is added to the transaction pool and waits there to be validated by the miner. Transactions in the pool are sorted by gas price. This is fee optimization by the miner. We can see all pending transactions at etherscan.io. So at this moment, we have 68,462 pending transactions. So transactions that are in the transaction pool and haven't been mined. At step number 5, the miner finds a valid block by solving the proof of work puzzle and adds the new block to the existing blockchain. The number of transactions in the block depends on the block gas limit. In the last step, the miner node broadcasts the new block to all other nodes. All nodes execute the transactions from the new block, but only the miner gets paid. The miner receives a block reward that is at the moment of 3 ethers and the cumulative gas from all transactions from that block. This is how new ethers are created. Every new block creates 3 new ethers. We must also know that the Ethereum blockchain can process 15 transactions per second and the block time is 20 seconds. So every 20 seconds a new block is created. A block is considered final and forever added to the blockchain after 12 confirmations. Block confirmation counts how many other blocks have been created and added on top of this block. For example, if 5 new blocks have been mined and added on top of my block, it is said that my block has been confirmed 5 times. We have 5 confirmations. The more confirmations a block has, the less chances that block has for an inside transaction to be reverted. If someone wants to revert or to modify a transaction, it must recalculate and validate all blocks that stay on top of my block. Let's see now what are the transaction fields. A transaction contains the signature of the sender, a recipient Ethereum address, an amount of Ether sent from the sender to the recipient if this transaction sends Ether. This transaction could, for example, deploy a contract or could call a function from a contract. So it's not mandatory for this transaction to send Ether. The value could be 0. Then we have the gas limit. The gas limit represents the maximum number of computation this transaction is allowed to perform. The gas price represents how many ways do I agree to pay on gas unit, and then the data field, which is optional, contains the contract byte code if this transaction deploys a new contract, or the function arguments if this transaction calls a function. The data field is empty if this transaction only sends Ether from one account to another. The nonce is a counter that starts from 0 for every account and then is incremented by every transaction and guarantees that the transaction is not sent twice. We must know the differences between a transaction and a call. A transaction modifies the blockchain, but a call doesn't modify the blockchain. If a transaction modifies the blockchain, it costs gas. A call is always free. A transaction must be mined. It doesn't happen instantly. It takes time. A call doesn't have to be mined. Its execution is instantly. A transaction returns a transaction ID and a call returns a value. For example, a call is get balance. We want the balance of a contract or the balance of an account. An example of a transaction could be a contract deployment or a token transfer transaction. Now, I want to show you an example of a transaction that I will generate using MetaMask. I open the MetaMask plugin, and from my first account that has a balance of 3.495 Ether, I will generate a transaction by transferring some Ether to another account. So I'll send to another account, to another address, to my third account, let's say 1 Ether. My transaction will be broadcasted and will use the Ringby test network. So these are test Ether. So they are not real, they don't value anything. I press on next. My transaction has been created, locally validated, and now using an Ethereum node, MetaMask isn't an Ethereum node, it's only a browser plugin, but behind the scene it connects to an Infura node that broadcasts further my transaction. So now when I will press on confirm, MetaMask will connect to Infura. Infura node will accept the transaction and broadcasts further to its peers. My transaction received a transaction ID or transaction hash. This is the transaction ID or hash, and it's in pending state. This means that my transaction belongs to the transaction pool. I must wait for this transaction to be mined. Okay, my transaction has been mined. I have 2 block confirmations. That means that 2 new blocks have been added on top of the block that contains my transaction. If someone, a malicious actor, wants to modify my transaction, he or she must recalculate the proof of work puzzle for those 2 blocks. And this is extremely complicated. Now I have 4 blocks confirmations. Ethereum considers a block finally confirmed after 12 confirmations. Bitcoin, for example, uses 6 confirmations. The block and the transaction have been mined. So the transaction has been sent from this account to this account. The value inside the transaction was 1 Ether. The gas limit was the standard transaction value of 21,000 gas. What does it mean? It means that my transaction consumed 21 gas units. And the gas price is this value. So this value for unit of gas. How much Ether did my transaction consume? It consumed 21,000 multiplied with 2 gigawatt. And that means 0.0000042 Ether. The value of the nonce field is 13. That means that this account has already sent 13 transactions. This value starts from 0. One more thing I want to tell you is that a transaction can wait for days or even for weeks in the transaction pool until it is confirmed. More than that, the transaction can be discarded from the transaction pool because the pool is finite. If I send a transaction and it doesn't get confirmed, I can generate and send the transaction one more time. In fact, I duplicate the transaction with the same nonce value. This is very important, in this case 13, but with a gas price value higher, so higher than 2 gigawatt. My new transaction will replace the old transaction from the transaction pool, and having a gas price higher has greater chances to be validated faster. An important security remark is that the first 2 steps don't require an online connection. What does it mean? It means that the client can construct and sign the transaction without being connected to the internet. When signing the transaction, the client has access to the private key. A hacker that has installed a malware or can access our computer can also access the private key. Let's see if there is anything we can do in order to prevent this kind of serious security incident. We can, for example, sign the transaction on an offline computer that has never been connected to the internet. On that computer, we sign and save the transaction, and then we copy the transaction to an online computer that is connected to the internet, and from the online computer, we broadcast the transaction to the Ethereum network.